Hey people, and welcome to this video. In this video, we'll be working on the grade 12 mathematics paper 2 for November 2021. This paper is worth 150 marks and the time allocated is 3 hours. Looking at the instructions, make sure to round off to 2 decimal places unless stated otherwise. The diagrams are also not necessarily drawn to scale. And remember that you have an information sheet with formulas at the end of the question paper. Okay, with that being said, let's get into this video. Question 1 says, a bakery kept a record of the number of loaves of bread a tuck shop ordered daily over the last 18 days. The information is shown in the table below. And they want us to calculate the mean number of loaves of bread ordered daily. Okay, so we can actually just use our calculator for this. So on your calculator, to put in a type of data that only has one variable. Okay, we only have one variable. We're not working with a bivariate data set here. So you're going to press mode and then go for the option stat. But instead of going for a plus bx, you go for one VAR, okay, one variable data that we're looking at. Okay, and it's going to look like this. And then we'll put down all our information so that we can find the mean and any other thing that they asked for. Now notice that in some places you have double of the same number, okay? If you have a repeat of the same number, you don't have to write it twice. You could simply just write it. For example, we have 10, 11, 13, and then we have two sets of 14. So you could say 14, and then to ensure that it does record two sets of 14, you go to the frequency column and you change that to 2, and that would record like that. Okay, and so on. Now, once you have input the data, you can press AC, Shift, and 1. And then you'll see a couple of options, but you just need to go for option number 4, variable. And then we're looking for the mean. So that would be the mean, like that. So let's see, the mean is exactly 22. So that would be the mean number of loaves of bread ordered daily. 22 loaves. Okay, and that is our answer. Moving on to the next question. Question 1.1.2 asks us to find the standard deviation of the data. Okay, so with the standard deviation, again, we can just press AC, Shift 1. And then we're going again for variable, option number 4. And then the standard deviation. For the standard deviation, make sure to go for the option that looks like that. And that will be our standard deviation. So in this case, it's in decimals. So that is 10.17. And that is the standard deviation. Moving on to the next question. Question 1.1.3 says, we need to calculate the number of days on which the number of loaves of bread ordered was more than one standard deviation above the mean. Okay, so we're specifically looking for more than a standard deviation above the mean. So let's find out what exactly one standard deviation above the mean would look like. It's a single standard deviation above the mean. So wherever you have the mean, we're going to add a standard deviation. That would be one standard deviation above the mean. And so that is equal to, our mean is 22. And our standard deviation is 10.17. So that is 32.17. And we just have to find the loaves, the number of loaves that are more than this number, which represents one standard deviation above the mean. Okay, so we'll just have to see how many values are above this. Now, remember that these represent the days, okay? So each day they kept keeping record of the number of loaves. So how many numbers are above this? That's going to be 35, so that's 2, 3, 4, 5. That's exactly 5 days. So we can conclude it's exactly 5 days where we had the bread ordered was more than one standard deviation above the mean. And that is our answer. Moving on to the next question. Question 1.2 says, the tuck shop owner was not able to sell all the loaves of bread delivered daily. He calculated the mean number of loaves sold over the 18 days to be 20. So the mean is 20 now, not 22. Calculate the number of loaves which were not sold over the 18 days. Okay, so looking at the first question really, we know that the mean number of bread that was ordered daily was 22. So that's just the average number of loaves that was ordered daily. So if we knew that, it means that in order to get that, we must have said the sum of all the loaves that was ordered and then divided by the 18 days. Since we were trying to find out on average how much loaves was ordered per day. And when we did this at first, we got 22. But now they're specifically saying, so this would be the calculation for the loaves that were ordered. Now, what happens is that the tuck shop owner could not sell everything. Okay, when he calculates the mean number of loaves sold, it was exactly 20. So he added up all the loaves of bread again, and when he calculated the average of the ones sold, it was exactly 20. So that would be the sold. So to find the ones which were not sold, we would have to take the total of the ordered, okay, how many loaves exactly were ordered minus how many were sold. And then that will give us the ones that were not sold, the ones that were left over. Okay, let's go ahead and do that. We can just go ahead and call it different things. So I'll call that the sum of the loaves. X is really just the loaves, okay, and I'll call that 1, and I'll call that one 2, just so that because we know it's going to be different, okay? The ordered and the sold are two different numbers. Okay, so in this situation, this is just our variable, and we're trying to solve for that variable. It's kind of looking at this as if it's just X on its own. So to solve for that, we can cross multiply. So that times the invisible denominator of 1 stays the sum of the loaves, okay, x1, is equal to, and then 18 times 22, which is 396. So that's 396. So what this means is the total number of loaves ordered was 396. Now let's see the total number of loaves sold. So we'll cross multiply again. So that would be the sum of the loaves sold is equal to 18 times 20 is 360. So there we go, this 360 sold. So to find out the ones that were not sold, we simply take the difference, okay? The total that was ordered minus everything that was sold will tell us what is left over. And so that would be 36. And that is our answer. The total loaves not sold were 36 loaves. Moving on to the next question. Question 1.3 says, one of the toolbox and whisker diagrams drawn below represent the data given in the table above. Okay, and 1.3.1 says, which one of the toolbox and whisker diagrams drawn above correctly represent the data? Write down a reason for your answer. Okay, so let's see. We just have to look at the data and compare it with this. Just remember what these points represent, and that would really just make the whole difference. This would be the minimum, the smallest value we have, the lowest value. That would be the maximum. This would be Q1, that would be Q2, and that would be Q3. And so if it does not match the data, then you know it's not that one we're going to choose. Okay, remember likewise for this one as well. Okay, so let's go ahead and see what we have here in our data. So notice our minimum is 10 and our maximum is 41. Let's see what we have. Minimum is 10 in both, as we can see, and the maximum is 41. It's also in both. Okay, so we're going to have to use something else to see that. Let's go ahead and check for the median here, because the median, they're completely different. Here it's 30, here it's in between 18 to 20. So let's go ahead and see what the median is here. The median would be marked at exactly half your data set. Since there are exactly 18 days, then if you count from 10 all the way to here, this is 9 on top and 9 on the bottom. So because it's an even number, you would have to take the two middle numbers, which would be exactly at 18 and 19. And so if you said 18 plus 19, then you would have to divide them by 2 to get the exact middle. And if you divide by 2, that will be 18.5, okay? Because you're just taking 1 out and sharing it in half. So 18.5 is our median. And yeah, that is definitely 18.5. We know it's not this. So you see the one main thing that we were able to use to differentiate between those two graphs. So it means that it is graph B, and our reason would be because of that median, okay? Graph B, and the reason is because the median is equal to 18.5, and that's exactly what graph B reflects as well. Okay, and that is it for that question. Moving on to the next question. Question 1.3.2 says, describe the skewness of the data. So the graph that we chose, how is it skewed? So when you're thinking about the skewness, I want you to think about it as if you are standing looking to the front, okay? So if you were standing looking to the front like that, then this hand side, this would be your right, and this would be your left. Now, based on that, how is this data skewed? The only thing you have to focus on is really these quartiles, okay? Q1, Q2, and Q3. If you notice that Q2 is closer to Q1 than it is to Q3, then this is skewed to the right, and that is the skewness. Okay, so the data is skewed to the right. We can, of course, also call this positively skewed. And that is our answer, and that is it for question 1. Question 2 says, a farm stall sells milk in 5-liter containers to the local community. The price varies according to the availability of milk at the farm stall. The price of milk in rands per 5-liter container and the number of 5-liter containers of milk sold are recorded in the table below. Okay, so we have a bivariate data set, okay, 2 variables that we need to consider. And question 2.1 says, on the grid provided in the answer book, draw the scatter plot to represent the data. Okay, so naturally you'll be given a graph already. You're going to be given graph paper, and so this will be a little more simpler to draw. So the title is really just a scatter plot, so you can simply name it. And then we need to consider what our x and y axes are going to look like. You see that the numbers are pretty high. You just have to look for a consistency in them. Normally, you guys would already be given the numbers, so I'm just going to follow that. Okay, you'll be given a numbering system. So we'll simply have our y-axis and our x-axis. And let me just go ahead and draw that out first. Okay, so here is our scatter plot. So we're just going to take from here, and we're just taking the x and y values. So for example, 26 and 48. 26 is about here, and then 48 is roughly in the middle here. So that would be 26 and 48. And you just do this for all of these values, taking the x and y values paired together. Okay, and I'm just going to fill this in. And there we go. Here is our scatter plot. And that is it for question 2.1. Moving on to the next question. Then question 2.2 says, determine the equation of the least squares regression line. Okay, so we know that the equation of the least squares regression line for the data looks like this. Y equals a plus bx. Okay, it's the equation of a straight line. So all we have to find is the value of a and the value of b. So we're going to need our calculator. So on the calculator, you can go ahead and press mode and then stat. And then we're not going to go for one variable data. Okay, we're going to go for bivariate data set. So we will go for a plus bx. And that is this option over here. Okay, and we're going to put down our data as we have it here. So the x values go to the x column and y's go to the y column. Once the data is all put in, we're going to press AC Shift 1 and then go for the option that says regression, REG. So that's option 5 on the Casio calculator. And when we go for option 5, you'll see that we can see the values of A and B. So we just need that. So A is equal to, that is 90 point, rounded up to 2 decimal places, that is 4/8. And then B is equal to, and again, you can just press Shift 1 to pull up the data again and then go for regression. And then B is simply negative 1.77. Okay, so if we fill that in, that is simply y is equal to 90.48 minus 1.77x. And that is the equation of our least squares regression line. Moving on to the next question. Question 2.3 says, if the farmer sells a 5-liter container of milk for 38 Rand, we need to predict the number of 5-liter containers of milk he will sell. Okay, so we're just going to have to find out the price of milk. Is that the X, or those the X or our Y values? As we can see, the price of milk, those are our X values. So we're going to put, in place of X, we're going to put 38. So we can take the equation of our least squares regression line to make this prediction. Okay, and in place of X, we're going to substitute 38. You can still do normal calculations even when your calculator is in this mode. And so that is equal to 23.22. So roughly about 23 containers would be sold. And that is our answer. Question 2.4 says, refer to the correlation between the price of 5-liter containers of milk and the number of 5-liter containers of milk sold, and comment on the accuracy of your answer to question 2.3. Okay, so comment on how accurate this is. So this is based on the correlation coefficient. So that is the value of R. It tells us how reliable the relationship between our two variables are. So does the price of milk affect the number of units of milk sold? Okay, so how we find that value of R, you can just go ahead and you just have to press AC to remove it. I have to actually remove it. So AC, Shift and 1 so that we can get back to this information. You're going to have to choose option 5 to go to regression first, and then we can see our correlation coefficient R. Okay, so you can see it is negative 0.94. Now, here's the reason it is negative, and this is not really a problem. It is negative because of the trend of your data. Notice that it is generally decreasing, which makes perfect sense because a higher price of milk would mean lower units would be sold naturally. Now, is this data, now that we have the correlation coefficient, we should probably also tell them its strength, okay? So it's just negative because of the trend of our data. Now, from our correlation coefficient scale, we'll know that this is in the range of a very strong correlation. So we can just state the correlation that we have. We have a very strong negative correlation. And so that, of course, makes the information that we found here to be pretty accurate. So we can say that the accuracy will be high. Okay, so in general, there is a very strong relationship between the price of milk and the number of containers sold. Okay, and that is it for question 2.4, and that is it for question 2. Question 3 says, in the diagram, A, which is 2 and 10, B, K and K, and C, 4 and negative 2, are the vertices of triangle ABC. Line BC is produced to H and cuts the x-axis at E, which is 12 and 0. AB and AC intersects the x-axis at F and G respectively. So those are the x-intercepts of those two lines. The angle of inclination of AB is 81.87 degrees. And question 3.1 says calculate the gradient of, and 3.1.1, BE. Okay, so looking at BE, we have B, which is missing, and E. Okay, but here's the thing. On this line BE, we also have another point, C. They are collinear, meaning they share the same gradient. The slope is exactly the same since it is consistent, it's constant. So let's go ahead and find the gradient of CE, and that will be the gradient of BE. So we're taking the points C, which are 4 and negative 2, and e, 12 and 0. And finding the gradient, we know that the gradient is equal to y2 minus y1 over x2 minus x1. And this is equal to, so we can just go ahead and follow one order. Top minus bottom is fine. So we can say bottom minus top, that is fine. So that is 0 minus negative 2, which becomes minus minus, which is a plus, all over 12 minus 4. Okay, 0 plus 2 is 2, and 12 minus 4 is 8. So 2 over 8 is equal to 1 over 4. And then we can just conclude, therefore, the gradient of BE is simply equal to 1 over 4. And that is our answer. Question 3.1.2 says we need to calculate the gradient of AB. Okay, so looking at AB, you see that AB, we have A and we don't have B. Okay, so we can still find this because despite the fact that we don't have the two coordinates, the full coordinates, we have the angle of inclination. The angle of inclination is 81.87 degrees. So here's how we can find that. What is the formula to find the angle of inclination? We simply say tan of theta is equal to that gradient. Here's the thing, we already have the angle of inclination and it's an acute angle, so there's no confusion with this. Since it's 81.87, we'll say tan of 81.87 degrees is equal to the gradient, and let's go ahead and find that gradient. So to find the gradient, we're just going to substitute this and it will give us the gradient. So let's do that on our calculators. So we're simply saying tan of 81.87 degrees, and that is exactly 7. You see that even if we try to round off, it's still 7. So the gradient of line AB is 7, and that is our answer. Question 3.2 says, determine the equation of line BE in the form of y equals mx plus c. Okay, so BE is this line over here, which we have the gradient of. The gradient is 1 over 4, so let's use the gradient and then just 1 point. Take an easy point. 12 and 0 seems quite simple, so we can take that. So you can use y equals mx plus c, or you can use y minus y1 equals the gradient and then x minus x1, which I'm going to go with. So let's go ahead and do that. We know that the gradient is 1 over 4, and we are using the point E, 12, and 0. So we're saying y minus y1 is equal to the gradient of 1 over 4 times x minus x1. Now just substitute that point in place of x and y. So y minus 0 equals 1 over 4 multiplied by x minus 12. And so this is simply y, because y minus 0. And then if we distribute, we have 1 over 4x, and 1 over 4 times negative 12 gives us negative 3. And that is our answer. Question 3.3 says, calculate 3.3.1 the coordinates of B where k is less than 0. Okay, so remember that B is the point on this line BE with k and k. It's beneficial that it's both k, since we can use them in an equation and they'll be in terms of k. So remember that B lies on BE. Okay, so since it lies on that line, this is the equation. That's the equation of BE. So let's go ahead and substitute k and k as the x and y coordinate. So that would simply be that k is equal to 1 over 4 k. We don't even have to put brackets. And then minus 3. And we can just solve for k. So that is k minus 1 over 4k is equal to negative 3. And k minus 1 over 4k is 1 minus 1 over 4. So that is going to be 3 over 4k is equal to negative 3. And then we need to solve for k. So to solve for k, we can get rid of this 3 over 4 simply by multiplying both hand sides by 4 over 3. So multiply by 4 over 3. And therefore, k is equal to, here diagonally we can see the 3's would cancel, so we'll have negative 4. And there we go. We can see that k is really less than 0. And that is our answer for k. And then they specifically ask for the coordinates of b. So b is simply negative 4 and negative 4. And that is our answer. Question 3.3.2 says calculate the size of angle A. Okay, so looking at angle A, that is this angle over here. How can we find this angle? So there will be various ways of finding it, but let's go with the angle of inclination method. And how we'll do that is we will find that point where A is created, okay, at that vertex. So we can go ahead and draw an imaginary x-axis since the angle of inclination is formed with a line and the x-axis, and we're going to move it to that vertex, so right over there, so that we can better understand how that angle was created. Okay, and now we can just extend these lines. Let's extend this. I'll use blue for this. We can extend this line of, that was AB, right? We can extend that line, and let's extend the line of AC. Okay, just ensure that this actually does lie on the same line. Okay, that is AC because they said that we have in the diagram this ABC of vertices of triangle ABC, and you can see that G is a point on AC. So G and C lie on this same line. So to find this, we can simply find the angle of inclination, looking at this as the x-axis. We're going from the x-axis all the way to that line of AC. And if you take that and you subtract it by the angle of inclination of AB, okay, from the x-axis to AB, do you see that you'll be left with this part over here? And this is vertically opposite the angle that we're looking for. So it represents the same thing. So clearly that's what we need to do. We can find the angle of inclination of AC and subtract it by the angle of inclination of AB, which, by the way, we already have. The angle of inclination of AB is 81.87 degrees. So to do this, we need to first find the gradient of AC. So let's go ahead. We need A, -2 and 10, and C, 4 and -2. So the gradient of AC would be found by saying y2 minus y1. We can just say top minus bottom. So that would be 10 minus -2, which is a +2, over -2 minus 4. So -2 minus 4. And this is equal to, that would be 12, and that would be -6, which give us -2. So now we know that the gradient of AC is -2, and now we can find its angle of inclination. Now notice we're specifically looking for that obtuse angle, okay? See, it has a negative gradient because the line is a decreasing function. It's moving down. So to find the obtuse angle, here's how we can just do that. We can go ahead and use the formula to find the angle of inclination, which is tan theta is equal to your gradient, which is -2. So we're trying to find theta of AC specifically. And then we can make theta the subject simply by using the second function of tan on both hand sides. So that's like leaving theta here, and then it's like transposing tan. So that is going to be shift tan or arctan, the inverse of tan, and we have -2. And let's go ahead and see what happens when we do that immediately on the calculator. If you say shift tan -2, you see that we get a negative angle. Now, in order to get the obtuse angle and not the negative, okay, because it's actually taking the negative, that would be the size of this angle over here, or you could also look at it as this angle over here. So since we don't want this one, we want this angle, we are going to add 180 degrees. So you add the negative, you add 180 degrees, you get to 0, and then you get to this point, and it will give us that size. So if you say plus 180 degrees, you see, there we go, it gives us that obtuse angle. So add 180 degrees, and AC is therefore equal to, it is 116.57 degrees. And at this point, it's fine to round off since that angle, the acute angle, was already rounded off, so it's fine. But you can also use this. Okay, and so finally, to find the angle that we're looking for, angle A, we're going to say the angle of inclination of AC minus the angle of inclination of AB. So the obtuse minus that, 81.87 degrees. So angle A is equal to the angle of inclination of AC minus the angle of inclination of AB. So we'll say 116.57 degrees minus 81.87 degrees. So it's really all of this minus 81.87, and that gives us exactly 34 points, and that's going to round up. Okay, so it's going to add a 1 to the 9, and then that adds a 1 to the 6. So that is 34.7 degrees, and that is the size of angle A. Question 3.3.3 says, calculate the coordinates of the point of intersection of the diagonals. So this is what they want us to find, the point of intersection of the diagonals of a parallelogram ACES, where S is a point in the first quadrant. Okay, so we are going to have a parallelogram here, and they want us to find the points of intersection of the diagonals of this parallelogram. And it's formed by joining A, C, E, S. And S is in the first quadrant. So it's going to look something like that, where S is over here. So we don't really know what S is. S, we can just call that X and Y. We don't know the coordinates. Now they want us to specifically find the points of intersection of the diagonals. So if we were to draw these, okay, so from A to C, like that, and another diagonal over here joining A and E, we have to find that point of intersection. Okay, so looking at this parallelogram, we know that in a parallelogram, right, that point of intersection would be the midpoint of both diagonals. So that is the midpoint of CS, but you can see that we don't have S, so we can't use that point. But it is also the midpoint of AE. So to find that, we simply have to find the midpoint of line AE, and that would serve as the point of intersection of your diagonals of this parallelogram. So here's A and E, and we're trying to find the midpoint. So the midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. And now the midpoint of AE is simply found by saying, we can say negative 2 plus 12 over 2 and 10 plus 0 over 2. Okay, so just simplify that and that would be our answer. The midpoint of AE is 12 minus 2 is 10, divided by 2 is 5, and 10 plus 0 is still 10, divided by 2 is 5. So 5 and 5, and that is the midpoint of AE. Okay, so the diagonals would specifically intersect at 5 and 5. So the diagonals of ACES intersect at 5 and 5, and that is our answer. Question 3.4 says, another point, T, which is P and P, convenient that they are in terms of the same letter, where P is greater than 0, is plotted such that ET is equal to BE, and they're both equal to 4 square root 17 units. And 3.4.1 says calculate the coordinates of T. Okay, so we don't really need the diagram for this because regardless of what it looks like, we just know that ET, right, is equal to this line BE. So we can just do a quick sketch over here. We had E and T, so regardless of what it looks like, we just know that T is in the first quadrant and E is over here, and ET is equal to BE. So we can go EB. Okay, so if that was B over there. And we just need their coordinates really. So T is just P, and let's see what E and B are. E is 12 and 0, B is K and K, which we already found to be negative 4 and negative 4. So since we know they're exactly the same length and they're both equal to this, we can use the distance formula since they're referring to the lengths. So we know that BE and ET are exactly the same. Now, since we already know the length, we can just substitute in place of BE because we don't need to calculate this. We already know it is 4 square root 17 is equal to, and with ET, we're going to substitute the points. So we can start with top minus bottom. To find the distance of ET, we use the distance formula, which is x2 minus x1 all squared. So in place of x2 and x1, we can just substitute. That's going to be P minus 12 all squared plus y2, which is P, minus y1, which is 0 all squared. Okay, so this is what we have. Now, notice at this point, the square root is in the way and we need to get rid of it to solve for p. So we can simply square both hand sides and that breaks open that radical. So here when we square, the 4 gets squared to become 16 and then the square root of 17 gets squared and that radical breaks open and we have 17 is equal to, that breaks open there and we have p minus 12 all squared, which we can just distribute at this point. So p squared gives you p squared. Then the last term squared, negative 12 squared, is positive 144. And then first term times second term gives you negative 12p. Then you multiply that by 2. So that is negative 24p. Over here, p minus 0 is simply p. So p squared, we have plus p squared. Okay, so this is going to be 2p squared minus 24p and then plus 144. When we multiply 16 and 17, and just quickly find that 16 times 17 is 272. So 272 and you have 144 and 272 will come over becoming negative 272. Okay, so let's just see what that is quickly. 144 minus 272. And that gives us negative 128. So when we subtract there, we get negative 128. Notice that they are all divisible by 2. So we can divide both hand sides of the equation by 2. And now we get, so let's just start with these. So that's going to be p squared minus 12p. 128 divided by, so that is 64. Negative 64 is equal to 0. And now we have to factorize. So open up two brackets and we have p multiplied by p is equal to 0. And now we need factors of 64. So negative 64. Specifically, that gives us negative 12. You know, you can't try 8 and 8. It's not going to work. So let's try something bigger. Try something like 16 and 4. Okay, 16 times 4 is 64. So if you make, to ensure that this stays negative, we can make the 16 negative and the 4 stays positive. So plus 4. So negative 16 plus 4 gives negative 12. And there we go. That is the middle term's coefficient. So those are our factors. Negative 16 and positive 4. And so therefore, p is simply equal to 16 or p is equal to negative 4 when that gets transposed. But let's see what they said about p. They specifically said that p is greater than 0. So it's not equal to negative 4, but p is equal to 16. And let's just ensure that we are answering their question. They say calculate the coordinates of t. So because t was p and p, therefore t is simply just 16 and 16. And that is our answer. Question 3.4.2 says, determine the equation of, and A asks for the circle with the center at E and it passes through B and T, and we need to determine this in the form of the standard form of a circle. Okay, the standard form of the equation of a circle. So with the standard form, remember that the coordinates A and B, those are the coordinates of the center. So that's where E's coordinates will go. So we know that E, we already have these here, is 12 and 0. That's 12 and 0. So we know that that's A and that's B. And then in place of X and Y, we're going to just find a point on the circumference of the circle. Clearly, we have 2 points, B and T, so we can choose between them. So this is simply going to be X minus 12 all squared plus Y minus 0. But here's the thing, if you say Y minus 0, that's just Y. And then it goes all squared. So this is just Y squared. Okay, so we have Y squared is equal to R squared. Now the only thing missing at this point is R squared. So to find R squared, we'll substitute 1 point on the circle so we can find that. We have 2 points. We have B and T. Let's just use the easier one. This is 16 and 16. Let's just go with negative 4 and negative 4. So B is negative 4 and negative 4. And we're substituting this in place of X and Y. So this is going to be negative 4 minus 12 all squared plus, and that is negative 4 all squared, and that will give us R squared. So let's find R squared. And that gives us 272. So 272 is equal to R squared. Okay, so therefore, this means that now that we have r squared, you can simply plug r squared into the equation that was almost complete. There we go. So it is x minus 12 all squared plus y squared is equal to 272. And that is our answer. Okay, an easier way to have done this is we didn't actually need to substitute x and y, because here's the thing. They told us that the center was E. Okay, if the center is E and we knew that ET and BE were both equal to 4 square root 17, then that was specifically the length of your radius. If this is a circle and this is the center of the circle, then from the center to the circumference, since B lied on the circle and so did T, then that would be your radius. Okay, so that's a situation that we actually have. So this would be r, and we would simply need to square that to get r squared. So we didn't actually need to do this. But that's also fine. Okay, moving on to the next question. Now B, the last question, says we need to determine the equation of the tangent to the circle at point B, which is K and K. We already have B. So here's the situation we have. We have a circle, right, with E being the center. That was 12 and 0. And then we know that B is one of the points on the circumference. And B is negative 4 and negative 4. And we just need to find the equation of the tangent, okay, to the circle at B. So from that, you see that we have everything that we need. We can go ahead and find the gradient of the radius. And we know that because of the relationship between a tangent and the radius at the points of contact, that they are perpendicular. So we can use the perpendicular properties of gradients to find the gradient of the tangent and then the equation of the tangent. Okay, so the gradient of BE, we already had the gradient of BE from, this was in the first question. The gradient of BE is 1 over 4, so we don't have to find this again. So we can simply tell them that the gradient of BE, our radius, is 1 over 4, okay? Okay, this is also the gradient of the radius. So because the gradient of the radius is 1 over 4, this means that the gradient of the tangent would be, you would simply take this, switch the numerator and the denominator, and then multiply this by negative 1. So if you switch, that is 4 over 1, and then times negative 1, it's negative 4 over 1, which is just negative 4. Okay, this holds the property that if you have perpendicular lines, then the gradient of the one line multiplied by the gradient of the other line give you negative 1. So if you want to find the gradient of one line, simply divide both hand sides by the gradient of the other line. And now that we have the gradient of the tangent, we can find the equation of the tangent. Notice that on this tangent, the only point we have is B. So we'll substitute that as our point. So we can go ahead and let's just use y equals mx plus c for this. So that is going to be y equals negative 4x plus c. And then in place of x and y, we substitute negative 4 and negative 4. So negative 4 is equal to negative 4 times negative 4 plus c. And c is then equal to, we have negative 4 here. These multiply to become positive 16, and they come over and become negative 16. So this is c is simply equal to negative 20. And so the equation of this tangent is y equals negative 4x minus 20. And that is our answer. And that is it for question 3. Question 4 says, in the diagram, the circle centered at N passes through A, which is negative 1 and negative 1, and C. Then we have B, negative 4 and 2, C, D, and E are joined to form a parallelogram such that BE is parallel to the x-axis. And lastly, they tell us that CD is a tangent to the circle at C, and CD is equal to 6 units. And the first question is to write down the length of the radius of the circle. Okay, so to find the radius, we know that the radius goes from the center of the circle to the circumference. But this point, these 2 points, you can see that they share the same x value. Okay, negative 1 and negative 1, meaning this is a vertical line. So to find the length of this line, you don't need the distance formula. You simply need to say whatever this y value is minus whatever that y value is, and that will tell you the length of the line NA. So we can find the radius or NA by simply saying negative 3 minus negative 1. So 3 minus minus 1, which is plus 1, and so that is equal to 4 units. And that is the length of the radius. Moving on to the next question. Question 4.2.1 says, calculate the coordinates of C. So looking at C is also that other point that is at the circumference. So how to find C? Notice that CD is a tangent to the circle. So it means that when we draw a radius, okay, which we already have the length of, we know that the radius and the tangent are perpendicular at their point of contact. So here's the thing. This is parallel to BE. But we also know something about BE and the x-axis. They told us that BE is parallel to the x-axis. So if BE is parallel to the x-axis, then CD is also parallel to the x-axis, meaning that because this line CN, the radius, is perpendicular to CD, a line parallel to the x-axis, then this line is a vertical line. So if it is a vertical line, it means that you see the point N, negative 1 and 3, C would also have the same x value, okay, because it's a vertical line. So we literally just move up by the distance of the radius to get to that point. And the x value is negative 1, making the y value. To find the y value, we already know that the radius is 4 units. So you're moving from N being the y value of 3, and you're moving 4 units up to get here. Okay, so that is going to be specifically here. Okay, that's going to be 7. So that's negative 1 and 7. And that will also be the coordinates of C. You can show them that you found the y value, how you found the y value. So we knew that the x value of C was negative 1, okay, because we had that CD is perpendicular to NC. We can call it NC, that's fine, or CN, okay. And so therefore, because it's a vertical line, to find the y value of C, we simply just said that 3 plus the 4 units. Just shift 4 units up, and that's 7. So therefore, C is simply negative 1 and 7. And that is our answer. Question 4.2.2, we need to find the coordinates of D. So D is over here. So that would be the same principle really, because this is a vertical line and it is perpendicular to CD. CD is a horizontal line. You know that the x value here was negative 1. So we're really just moving from negative 1, right? And we know that this is negative 1. And CD is exactly 6 units. So you're moving 6 units to the right to get to D. The only thing that changes, as you can see from this point over here to that point, is the x value. That x value now becomes negative 1 plus 6, which is 5. And the y value is exactly the same as C, since it is a horizontal line. This was 7 as a y value. This will also be 7 as a y value. So D is 5 and 7. Okay, the only calculation we would really have to put there is maybe the coordinates of 5. Okay, how we found that. So we can just simply tell them that to find the x value of C, we simply said negative 1 plus the distance of CD, which is 6. And so that coordinate is 5. And so therefore D is simply 5 and 7. And that is our answer. Question 4.2.3 says we need to find the area of triangle BCD. Okay, so let's go ahead and draw that. That is going to be B to C to D. Okay, so this triangle over here. So first, always try to use half base times height before using any other one, okay? Because it's the simplest way to find the area of a triangle. So do we have a base? Yes, we can use CD as the base of this triangle. It's 6 units. Do we have a height? We find the height by going from the highest point on the triangle to the perpendicular base, okay? Now the base, because this is an obtuse, well, it looks like right now, we haven't really found any angles, but it looks like an obtuse triangle. what we could do here is simply extend this base of CD. If you extend that, then we can better understand what the height is. The height will go from the highest point, and we can look at that as this point B over here. So if you go down, and we're going to draw a dotted line down to the extension of DC, then you can see that that is the height. Okay, and the height, we can find this because we already know what the y value of C is. It is 7. And we know what the y value of B is. It is 2. So the height is simply the difference between 7 and 2. So that is exactly 5 units. Okay, so this triangle has a height of 5 and a base of 6, so we can find the area. We can tell them that the area of triangle BCD is equal to a half multiplied by the base and multiplied by the perpendicular height. It always has to be perpendicular, and yes, in this case it will be perpendicular to the base because this is a vertical line and that is the extension of that base, which is a horizontal line. So this is equal to a half multiplied by the base of 6 units and the height of 5 units. So 6 times 5 is 30 times a half is 15. So this is 15 square units, okay? Okay, 15 units squared. And that is the area of triangle BCD. Question 4.3 says, the circle centered at N is reflected about the line y equals x. Okay, so this becomes the inverse of that circle. M is the center of the new circle which is formed. The two circles intersect at A and F. So keep that in mind. And they wanted to calculate the length of 4.3.1 NM. So to find NM, we just really need N and M. We know that M is the center of the new circle which is formed. Okay, so let's just get rid of some things here. So the line y equals x is like that. And when we have this line, what's going on is the circle will be reflected across this line. So it will still be the exact same size, same circle, just reflected across that line, giving you the inverse of this circle. Now, a circle is a cyclic shape with the same type of curvature all around. It's not like an oval, so it's going to still be a circle. And how we can see this, one of the ways that we can just work on reflecting this is we're going to take a point. Well, the point that we actually need is N. So let's just use N. And we know that if this is N, when reflected across this line, y equals x, it's going to form the inverse, meaning the x and y values switch places. That is all that will happen. So this being -1 and 3 will now be 3 and -1. Okay, so something like that. And that is M that they are referring to, 3 and -1. And they simply want us to find the length of that. Okay, so we'll just tell them what M is and then find the distance of NM. So here's a visual example of what happens. This will be reflected across that line y equals x. So it's a reflection. Well, it's going to actually flip over, of course, or just form a mirror image. But just showing what happens is that it moves like this. Now, there are certain points that would have to maintain. For example, you see this point A, which is -1 and -1. Notice that its x and y value are exactly the same. So it means that on the reflection, you're also going to have another point called -1 and -1. So it also has to pass -1 and -1. Okay, so maybe something like this. Okay, so something like that. And, I would probably just have to write this much closer. So I probably just drew that a little too far. So that would be about here, the center, and that is M. Okay, so that is 3 and -1. And we can just find the length of MN. Okay, so N is that, and so therefore M is this. So we'll have to tell them what M is. And now let's find the distance. So MN, we don't really need the formula. We already wrote it down at some point. So square root of x2 minus x1, we'll say -1 minus 3 all squared, plus y2 minus y1, and that is 3 minus -1, which becomes a +1 all squared. And let's just find the distance of MN. So MN is equal to 4 square root 2. Okay, you can round this off to 2 decimal places, which is going to be 5.66. It's going to round up 5.26, so 5.66 units, and that is the length of MN. Okay, and the final question for question 4 says 4.3.2, we need to calculate the midpoint of AF. Okay, so let's go ahead and look at our diagram. So with AF, remember that they told us what F was. They specifically said that A and F, the two circles, they intersect at A and F. So knowing that they intersect at A and F, A is clear, that's here where they both intersect. Remember how A is a point that is -1 and -1. It lies on this line y equals x. So I actually have to correct some things here, the way I drew some things. This line is actually more tilted like this, and then it passes that point A like that. Okay, so something like that, and A has to actually nicely touch that point over there. So do you see that they will both have a point of intersection at A and F? So F is the only one that we don't know. Well, we have to find that midpoint. But here is the interesting thing about this. Remember that this is the same circle, same radius and all, right? It has just been reflected across the line y equals x. So it also has a radius of 5. Notice that if we connect this over here, if we connect these two, A and M, you're going to have a horizontal line. So I should probably also just make this slightly, shorter than what I made it. Okay, so if you connect it, we have a horizontal line, and we know it's horizontal because they have the exact same y value. A has -1 as a y value, M has -1 as a y value, okay? And if you connect, and it's also a radius, if you connect N and A, it is a vertical line, okay? We already knew that from the first questions. Now, these have the same length. Remember, they're the same circle, same radius. So the radius of the circle was 4 units, okay? Remember, from the y value of 3 to the y value of -1. So this is 4 units. That's 4 units. If we also connect N and F, you also see that we have another 4 units length over there and another 4 units over here. This is a square, okay? So A and FM forms a square because of the symmetry that we have in these circles. So with that being said, so if we wanted the midpoint of AF, it would be finding the midpoint of the diagonal of the square. So that would be the midpoint of NM as well. So just find the midpoint of NM, and that would also be the midpoint of this AF, which is also the other diagonal of the square that we have here. Okay, now this is not something we have to find out. This is by observation. So just to add to this, we can just tell them about the lengths, right? That all of these lengths are exactly the same. And the last thing to do to prove it's a square would be to show them that we have a corner angle equal to 90 degrees. Okay, so we can just show them that AN and AM are going to be perpendicular at the point of contact, because we already knew that this was a vertical line, their x values are exactly the same, and this is a horizontal line since their y values are exactly the same. Okay, so those two things, all the lengths are equal, and we have a corner angle equal to 90 degrees. That will be how to prove that a shape is a square. So the length we're focusing on is AN equals NF equals FM equals AM. So they are all equal, and they are exactly equal to 4 units. And we know that AN is perpendicular to AM. Okay, so it makes that shape a square, which is ANFM. Okay, so that is AMFN is a square. And since we know that it's a square, we know that the diagonals would intersect at the same point. To be honest, we didn't really need to prove that it was a square, so you didn't really need this part. As long as it was a parallelogram, then the diagonals would intersect at the same point, okay? The diagonals would bisect each other, meaning they share the same midpoint. So now we can just focus on finding that midpoint. So we're saying that the midpoint of course, we were referring to the midpoint of AF, but of course we don't have F. So to find that midpoint, we'll use the midpoint of NM. So that is equal to x2 and x1, and we're going to just use it there. So that is, let's just say bottom plus top. So that's 3 plus -1, which is -1 over 2, and -1 plus 3 over 2. So the midpoint of NM is simply going to be, that is 2 divided by 2 is 1, and 3 minus 1 is 2 divided by 2 is 1. It's 1 and 1. And we'll also just tell them that the midpoint of NM is exactly the same as the midpoint of AF. So therefore, the midpoint of AF is 1 and 1. And that is our answer. So you could have just shown them this part and then concluded, rather than concluded it's a square, you could have skipped this and concluded that it's a parallelogram. And so because it's a parallelogram, their diagonals would intersect at the same point, meaning their diagonals bisect each other. And then you could have gone ahead to find that midpoint using the formula. Okay, so that is it for this question, and that is it for question 4. Question 5.1 says, without using a calculator, simplify the following expression to one trigonometric ratio. Okay, so we have been given this expression, and we just have to simplify when necessary. Okay, so let's simplify this. This would be equal to, we have sine 140 degrees. You know that 140 degrees lies in the second quadrant, since it is greater than 90 degrees but less than 180 degrees. And the reduction here is, this is where sine is positive, and the reduction is 180 degrees minus theta. So if you rewrite this as sine 180 degrees minus what angle would you subtract this by so that it remains 140 degrees? You subtract it by 40 degrees, okay? We're still maintaining what it is equal to. We're simply just changing how it looks so that we can better simplify it. And then using this reduction, since it is sine and sine is positive in this quadrant, it gets reduced to positive sine of 40 degrees, that reference angle that we had there. And then multiply by sine 360 minus x. Now we know 360 minus x is over here, and that is cos's quadrant. Okay, so cos is positive here, so sine is negative. So this reduces to negative sine x, and this goes all over. Now you see, immediately you have something like sine 40 degrees. You know that the only other thing it could cancel with is something that it probably shares a cofunction with. So now we have cos 50 degrees. You see that that's cos and that's sine. We could use cofunctions here. So we have cos 50 degrees. So that is cos 90 degrees minus what angle gives you 50 degrees? That's 90 minus 40 degrees. And then when applying cofunctions, it gets simplified to positive sine of 40 degrees. So you see that they are the same. And multiply by tan negative x. The angle is negative, so you can simply add 360 degrees to this. So tan 360 minus x, that is again in cos's quadrant, so tan is negative here. So this simplifies to negative tan x. And this is equal to, we can see that these would cancel since they're exactly the same, they become 1. And these are both negative, so those negatives would cancel. So what we have is sine x, and it's divided by tan x, and tan x can be expressed as sine x over cos x. So since we are dividing, we might as well say divided by sine x over cos x. And then at this point we can use, because we are dividing by a fraction, we can use the rule tip and times. So we'll leave this as sine x, and then we tip this, swap the numerator and the denominator, and we change the division to a multiplication. So this is equal to, as we can see diagonally, sine would cancel and you're left with cos x. And that is our answer. Moving on to the next question. Question 5.2 says, prove the identity. Okay, so we can see that we will be working with the left-hand side. So we'll say left-hand side is equal to, and then we'll just rewrite the left-hand side. Okay, and let's simplify. So let's just first inspect the numerator and just see the relationship between what we have it simplified to. It's 2 cos x minus 1. Notice there's no sign. So this sign needs to go. Now, there are various ways to get rid of this sign. One of the ways that we could think about getting rid of it would be, because it has 2 sine squared x, we know that there is a double angle expansion that includes 2 sine squared x, and that is 1 minus 2 sine squared x. This is equal to cos 2x. Now, I would want to use this, but the problem with this is that now you're going to end up including, if you're going to replace negative 2 sine squared x, right? Then it means you're going to have to transpose the 1, and you're going to have a cos 2x, which is nowhere in what we simplify to. So to avoid complicating things, let's just work with this more simply. We can change the sine squared x to this using the identity sine squared x plus cos squared x is equal to 1. So if we make sine squared x the subject, we know that that should be equal to 1 minus cos squared x. Okay, that's what sine squared x will be. So let's replace it with that. We have negative 2, and then in place of sine squared x, we say 1 minus cos squared x. Okay, so that's that part. And then we'll say plus cos x plus 1. Okay, great. Nothing has sine, and that's fine. We just have to simplify as far as possible. Now notice that here we have an angle greater than 360 degrees. Whenever you see an angle greater than 360, simply subtract 360 degrees so we can better understand the angle. And that is going to be cos 540 degrees minus 360 is 180 degrees. And so that is cos 180 degrees minus x. Okay, and this is equal to, and here we'll distribute. So that's going to be negative 2 and then positive 2 cos squared x plus cos x and then plus 1. And this goes all over, and we have 1 minus, now cos 180 degrees minus x. The 180 degrees minus x is in sine's quadrant, and cos is negative here, so that becomes negative cos x. Okay, and in the numerator, this would simplify to, we're going to have a trinomial here, so we can just write the thing that is in terms of cos x squared first. So that's going to be 2 cos squared x and then plus cos x, and we have a positive 1 minus 2, which gives us negative 1. And this goes all over. Notice if these distribute, that becomes a positive. So this is really 1 plus cos x. I know that this is a trinomial, so just so that it has a factor, it's probably going to have a factor. Let's just put this in an order where cos comes first. So it's cos x plus 1. Okay, let's go ahead and factorize that numerator. You can use the k method substitution if this looks a little intimidating. So in place of cos x, you can replace that with k, and so your expression will look like this, to be 2k squared plus k and then minus 1. But we could also just factorize it like this. So we'll open up 2 brackets, and we'll have to say what times what gives us 2 cos squared x. That will be 2 cos x multiplied by cos x. And what times what gives you a 1? Well, that will be 1 times 1. But remember that this is the negative 1. So we need to have it be negative at the end, but when added, it should give you positive cos x. Think about it like this. When we are foiling out, right, that becomes the 2 cos squared x. And if you distribute like that, then you're going to have a 2 cos x. Now, should this be positive or negative so that this one remains positive? You should probably leave it positive and then give the negative to this value over here. So you can say negative 1 multiplied by cos x, and that gives you negative cos x. And like that, positive 2 cos x minus cos x is equal to cos x, and that is our middle term. So we can change that to a plus, and this is a minus. Okay, so this is what our factorization looks like. And then we have cos x plus 1. Notice that we have common factors in the numerator and denominator, so they cancel. And finally, our answer is indeed 2 cos x minus 1, which is equal to the right-hand side. And there we go, we have proven this identity. Moving on to the next question. Question 5.3 says, given sine of 36 degrees is equal to the square root of 1 minus p squared, without using a calculator, determine each of the following in terms of p. And the first one is tan 36 degrees. So notice from the question that this is going to be a diagram because they've told you that sine 36 degrees is equal to this value. When we look at where 36 degrees would be in our cos diagram, or in our Cartesian plane really, we can see that 36 degrees is going to be in the first quadrant. Okay, if we measure 36 degrees, since it is an acute angle, it's in the first quadrant. So that would be 36 degrees over there. And when we line this down to the x-axis, it's perpendicular to the x-axis. And what they're telling us is that sine 36 degrees is equal to this value. Now remember that sine is opposite over hypotenuse. So meaning that this is the opposite side and the hypotenuse is the denominator here, which is an invisible 1 that we have. So the hypotenuse is 1 unit and the opposite side is the square root of 1 minus p squared. Okay, so we just need to find the adjacent side. Using Pythagoras, we would say the hypotenuse squared. So to find that adjacent side, let's go ahead and call it x. So to find x squared, we'll say the hypotenuse squared minus one of the smallest side squared. So that is the square root of 1 minus p squared, all squared. And so x squared is equal to 1. And there the radical breaks open, giving you in the brackets, because it's still two terms, it's 1 minus p squared. And then when we distribute, this is 1 minus 1 and then plus p squared. You see that the ones cancel and x squared is equal to p squared. Therefore, if you square root both hand sides, of course we would have to consider the positive and negative solution, but we're solving for x and you can see that x is in the positive part of the x-axis. So it's going to be positive p. So there we go. Okay, so x is equal to positive p, and we can put that down there. So to find tan 36 degrees, remember that tan is opposite over adjacent, okay, the TOA part. So we'll say the opposite side, which we can see opposite 36 degrees is the square root of 1 minus p squared over the adjacent side, which is p. So our answer here is simply the square root of 1 minus p squared over p. And there we go. That is our answer. Moving on to the next question. Question 5.3.2 says we need to find the value of cos 108 degrees. Now, notice this is an obtuse angle, so we can reduce it using the reductions to become an acute angle. So we can better understand this. It'll probably include a 36 degrees. So when we reduce this, since it's 108, it is in sine's quadrant. And so you have to use sine's reduction, 180 degrees minus theta. If we use that, saying cos 180 degrees minus what gives us 108 degrees, that would be minus 72 degrees. And so this gets reduced to, because it's not in cos's quadrant, it's in sine's quadrant, it gets reduced to negative cos of 72 degrees. So the whole point is to relate it to 36 degrees since that is the reference angle we have there. So this is going to be equal to, we have 72 degrees is actually double of 36 degrees. So this is negative cos and this is double of 36 degrees. That would give us 72 degrees. So looking at that, that is using double angles. So we can expand this to one of the double angle formulas that we know. It's best to expand it to something simple, something that includes something we already have. Now, we already know what sine of 36 degrees is, so we might as well expand this to the one with sine, which is going to be, we still have that negative outside, but this now becomes 1 minus 2 sine squared of half of the angle. The full angle, the double angle, is 72 degrees. Half of it is 36 degrees. Okay, and we know what sine 36 degrees is, so we will be able to find this. Okay, so simplify, we can distribute. So we have minus 1 and then positive 2 sine squared of 36 degrees, and we just have to substitute at this point. So this is equal to minus 1 plus 2, and sine squared of 36 degrees. Sine of 36 degrees was already the square root of 1 minus p squared. So we'll just put that in place of sine 36 degrees, square root 1 minus p squared. But remember that this is squared, so we need to square that. Okay, so this is equal to -1, and then we have plus 2. And in here, what happens is that square breaks that square root, and we have 1 minus p squared. And this is finally equal to -1, and distribute the 2. It's positive 2 minus 2p squared. And finally, our answer is 2 minus 1 is 1 minus 2p squared. And that is our answer. And that is it for question 5. Question 6, 6.1 says, given cos alpha minus beta is equal to cos alpha cos beta plus sine alpha sine beta, we need to use the given identity to derive a formula for cos alpha plus beta. So use the rule that is used here to derive a formula for this. So we are trying to derive a formula for cos alpha plus beta, but using this rule. Now notice that with this rule, we have cos alpha minus beta, but here we have cos alpha plus beta. So we need to ensure that the middle is negative. We need to ensure that we are subtracting two angles. We need to ensure that we are subtracting. We need to ensure that two angles are being subtracted. So this is really like cos of one angle, a first angle, minus a second angle. So to change this to a negative, we can simply express it like this. Cos of alpha, and then say this is minus, and then we're taking a negative out of that positive. It's like taking a -1 as a common factor out. So we're saying minus, and then what will be left here would be negative beta. And that is the only way we would end up with alpha plus beta again. Okay, so this is what we have. And now we're going to use the rule accordingly. So this is equal to, just like this was equal to cos of alpha minus beta, cos of your first angle minus your second angle is equal to cos of that first angle. So we'll also follow that, cos of the first angle multiplied by the second angle. And the second angle here was beta. And the second angle here was beta, but our second angle here is negative beta. Again, it's the same idea, cos of a first angle minus a second angle. So we're saying cos of negative beta. And then because they had a minus in the middle, they changed the sign to a plus. So we'll also change it. And this is sine of the first angle. And so we'll also say sine of. And so we'll also say sine of the first angle, which is alpha over here. And then sine of the second angle, which is beta for them, but ours is negative beta. So negative beta. And now all we have to do is simplify. So this is equal to cos alpha, and cos negative beta, when the angle is negative, you simply add 360 degrees. If you add a 360 degrees to this angle, it becomes cos 360 degrees minus beta. Notice that 360 degrees minus beta is in cos's quadrant. So cos is positive in this quadrant, and this simplifies to positive cos beta. Then this is positive sine alpha, and it multiplies to sine negative beta. So again, we'll add 360 degrees, and that becomes sine 360 degrees minus beta. And if you reduce that, because it's in cos's quadrant, sine is negative in this quadrant. So it becomes negative sine beta. And so now this is finally equal to, we're going to say cos alpha, cos beta, and these two multiply and become negative. So negative sine alpha, sine beta. And there we go. We have created a formula for this, derived a formula for this using this idea. And that is our answer. Question 6.1.2 says, simplify completely. So we have 2 cos 6x and cos 4x. Then we have minus cos 10x and plus 2 sine squared of x. Notice that these are 3 separate terms. And because they are 3 separate terms, there's some simplifying that needs to happen, but we need to think about it carefully. We have 6x and 4x. Then we have a 10x here. Well, 6 plus 4 is 10. So if we could change this to cos 6x plus 4x, it will expand to something that will help to subtract a term here. It will expand to something that will help to simplify with this one. So we can simply just say this is equal to, keep this exactly the same, we'll leave it like this, and that is 6x and then cos 4x and minus, and we'll change this to cos of 6x plus 4x. And for now we can just leave that because there's not really much to do to it yet. We can't really see what we should do to it. Okay, now this becomes cos. Now this is 2 cos 6x cos 4x, and this is minus. Now these will expand to something with 2 terms because we can use the compound angle formula here. So this is equal to, and that simplifies to cos 6x cos 4x. Okay, this is the one that we derive the rule for. Okay? And that becomes minus sine 6x sine 4x. Okay, close bracket. And then we have plus 2 sine squared x. And this is equal to, and now we see that it's going to distribute and simplify. So that is 2 cos 6x cos 4x. And then we have minus cos 6x cos 4x. And then that becomes a plus sine 6x sine 4x. And lastly, that becomes positive 2 sine squared x. Okay, this is finally equal to, and we have these two. Do you see that they are like terms? 2 of this minus 1 of this would simplify to cos 6x cos 4x. And then we add that to sine 6x. And again, we will be able to reduce using the compound angle formula there. Okay, and then sine, and then 2 sine squared x. So this is equal to, looking at this part, that would simplify to cos, and we have 6x, and because it's plus in the middle, okay, cos sine 6x 4x 6x 4x, that is going to change to a negative. Okay, it's like the one that we derived from, okay, this one. So they already have that there. Okay, and this is equal to, and then minus 4x. Then we just have a plus 2 sine squared x. And now at this point, we can start thinking about what to do with this. Do you see that this is going to simplify to cos 2x? What should we do to 2 sine squared x so that it has something to do with cos 2x? Okay, it will simplify with cos 2x because it needs to be simplified as far as possible. The thing with 2 sine squared x. So now looking at this, what can we change this to? Well, you don't necessarily have to change this one, but it would be easier to change this. Instead, what can we change this to so that it has something to do with what this simplifies to, which will be cos 2x. The thing about 2 sine squared x is that it actually has this. It is included in one of the double angle expansions, and that's the cos 2x is equal to 1 minus 2 sine squared x. Now, we can actually just make this the subject, but you might as well transpose it so it becomes positive. So it's now positive 2 sine squared x is equal to, and we have 1 here, then minus cos 2x. Okay, so it actually is equal to 1 minus cos 2x. So that will be helpful. Meaning this is equal to, that simplifies to cos 2x, and that simplifies to positive 1 minus cos 2x. And now you see that cos 2x and cos 2x would cancel, and your answer is finally 1. And there we go. That is our answer. It is equal to 1. Of course, this would also mean that you could have left this as cos 2x, and then that would have been plus 2 sine. And of course, this would mean that you could have left this as cos 2x and then changed it to the 1 minus 2 sine squared x, and it would have still cancelled with that positive 2 sine squared x. Okay, so the answer, all of that is finally just equal to 1. Question 6.2 says, determine the general solution of tan x is equal to 2 sine 2x, where cos of x is less than 0. Okay, and this is for 7 marks. So let's rewrite our equation first. Okay, and just keep in mind that cos x is less than 0. So simplifying this further, we can use the identity of tan x, which is sine x over cos x, is equal to, and this simplifies to, you see that we have sine 2x. So that is double angles. We can use the double angle identity for that. So that is 2 multiplied by, and then that becomes 2 sine x cos x. And so if we simplify further, this is simply sine x over cos x is equal to 4 sine x cos x. Okay, so at this point, notice that cos is in the denominator. So we should probably keep in mind that to ensure that we have real solutions, cos x shouldn't be equal to 0. But I'm not going to over dwell on this because they specifically do say that cos x should be less than 0. So we probably won't have this situation. Okay, now let's simplify. We can cross multiply, meaning we're going to say this multiplied by that, and that gives us 4 sine x, and then that's cos squared x is equal to, and we have sine x multiplied by the invisible denominator of 1, and that is sine x. Okay, at this point, see this, if you're trying to simplify and you try to divide both hand sides by sine, that is not a good idea. And the reason why is dividing both hand sides by sine is kind of like dividing both hand sides by x. If you're dividing both hand sides by x, you don't know what x is yet. X could be equal to 0, and then you create a case where you have an undefined value. And so we can't do that. So what we can do is transpose that sine x. So we have 4 sine x and then cos squared x minus sine x is equal to 0. And now we can just factorize. So do you see that in the first and the second term in this equation, we have sine x being common. So we can take sine x out as a common factor, and we are left with 4 cos squared x, and then that just becomes a minus 1 because that's all that will be left, is equal to 0. And now we just have 2 values multiplying and they give you 0. So it either means that the first one, sine x is equal to 0, or 4 cos squared x minus 1 is equal to 0. And let me just spread these apart since they will have solutions of their own. Okay, so sine x is equal to 0. Our reference angle, if we say shift sine of 0, is 0 degrees. So since 0 degrees is a non-negative, since 0 is a non-negative number, we're going to use the reductions where sine is not negative, okay? And that would be in the first quadrant and in the second quadrant, okay? So that is theta and 180 degrees minus theta. So when we're solving for x here, we'll simply say that x is equal to 0 degrees, then plus, now remember that this is a sine graph, and the sine graph will repeat itself every 360 degrees. So keep going 360 degrees later and even before this. So plus k of 360 degrees. Okay, and we'll say or, and the second solution we're using is where x is equal to 180 degrees minus 0 degrees, which is just going to be 180 degrees. And then plus k of 360 degrees. And then because this is a final solution, we can tell them where k is an element of integers. So here, where k is an element of integers. And we're done with this part. And now we're on to this part over here. So we're saying 4 cos squared x is equal to positive 1. And if we divide both hand sides by 4, we get cos squared x is equal to 1 over 4. Then we have to square root both hand sides because this is cos squared x. When you square root, because this is an equation, we have to consider the positive and the negative solution. But they said something important. They said that cos x is less than 0, the value of cos x. We're solving right now for cos x, okay? So when we square root cos squared x, we get cos x. And this is equal to, so we need to consider the negative solution. So that's going to be negative. Square root of 1 over 4 is 1 over 2. So this is what we have, and this is what we need to solve for. Okay, let's get our reference angle. So the reference angle will be found by saying you can take the absolute value of this because we're just trying to find that reference. So if we say shift cos of a half, we get 60 degrees, okay? Because shift sine of a half is 30 degrees, and those are complementary angles, they're cofunctions. So the reference angle is 60 degrees because that would be arc cos a half. Okay, so we've got that. And now how do we find our solutions? Well, cos is negative. So looking at the cos diagram, where is cos negative? Cos is negative in the second quadrant, in sine's quadrant, with the reduction 180 degrees minus theta, and in the third quadrant, in tan's quadrant, with the reduction 180 degrees plus theta. So we'll say that x is simply equal to, and we'll use that reduction. We're saying 180 degrees minus our reference angle, which is 60 degrees, and then plus, this is the cos graph, and the cos graph repeats every 360 degrees. So this is k of 360 degrees, or x is equal to, and that's going to be the second solution will be 180 degrees plus 60 degrees, and then plus k of 360 degrees. 360 degrees, and then let's just solve, and then we'll tell them that k is an element of integers. So 180 minus 60 is 120 degrees, then plus k of 360 degrees, or x is equal to 240 degrees plus k of 360 degrees, finally where k is an element of integers. And these are our solutions. So x is equal to 0 plus k 360, 180, and then 120 and 240 degrees. Okay, and that is our answer for question 6.2. Question 7 says, in the diagram below, the graph of f of x is equal to negative 2 sine x is drawn for the interval where x is an element of negative 180 degrees to 180 degrees. And here is our graph. Okay, and 7.1 says, on the grid provided in the answer book, draw the graph of g of x is equal to cos x minus 60 degrees for where x is an element of negative 180 to 180 degrees. Clearly show all intercepts with the axes. So this would be the x and y intercepts and the turning points of the graph. Okay, so this is the graph that we need to draw. For you to be able to sketch this graph, you need to understand what the original cos graph looks like, and then understand what exactly is being applied here. We have an x minus 60 degrees. This shift, whatever it is it's affecting the x. Okay, it's directly saying x minus 60 degrees. Now, if you subtract from the x, then this means that this is a shift to the right. If you add to the x, this is a shift to the left. So this means that this graph is shifting 60 degrees to the right. Okay, so it's just the natural cos graph shifting 60 degrees to the right. You know, the shape of the cos graph looks like this. Okay, so in our diagram, what that would look like, and you could do this part with a pencil first, would be like this. Notice that this goes from 0 degrees to 180 degrees. So it's not going to show that full shape. It's going to show half of it. It's going to show this part from 0 degrees to 180 degrees, which is over here. Okay, so cut it in half, and that's 180 degrees over there. So it needs to have that shape. So let's just do that first so that we can just understand what the shift would look like. So understanding the major point, it's going to have at 0 degrees, it will be equal to 1. This is the cos of x graph, right? And then at 90 degrees, it's equal to 0. And then at 180 degrees, it is equal to -1. So it looks like that, just, curved, and then it reaches there. Okay, so something like that. And then this side would do the exact same thing. It's also going from 0 to -180 degrees. So it will look exactly the same as well. It will do that. And then like that. Okay, notice that the minimum is at -1, not -2 like that, the graph we have. Okay, so if this is what cos of x looks like, then what would cos of x minus 60 degrees look like? This is going to be shifted to the right. So instead of having a y value of 1 at 0 degrees, this y value of 1 will appear at 60 degrees, okay, 60 degrees later. So you're really just taking this graph and you're shifting it 60 degrees to the right. They already cut these into 3 and you see we end at 90. So that is going to be 30, 60, 90. So at 60 degrees over here, this graph ends up here. So now we can just start writing down what the real graph looks like. The shift is going to look like that. That maximum will be there. And then this is another important point, an x-intercept. Where will this x-intercept appear? It's going to appear 60 degrees to the right. So 90 plus 60 is 150 degrees. So it's going to appear at 150 degrees. That is 90, it's counting in threes, okay? So 90, 120, 150. And that's where that appears. Okay, and so on. And then another important point would be this here, where it's equal to -1, because that is a turning point. And that happened at -180 degrees. It's going to now happen 60 degrees ahead of this. So you're just moving 2 places, okay? 30 and then 60. So it just appears here at -120 degrees. And then you can just join your graph. It's going to do that, curve up and then down. Okay, and then at this point, you can just erase that one that helped to find what this graph looks like, and then just complete it, because this is that new turning point that we have over here. You know that this is just going to curve upwards, and it won't, of course, reach the -180 degrees yet. And it will cut off at this point since we don't go anything beyond that. Okay, so let's just put down those important points. We know now that that is -120 degrees and -1. Okay, this over here is -30 degrees, which we already have there. We don't have to overthink that. And then over here, this maximum, this turning point over here is going to be at 60 degrees and a y value of 1. And we have 150 there. Okay, are there any other important points that we should note down? Okay, there is one more. Since these are turning points and x-intercepts that we have, okay, at -30 degrees and +150 degrees, then we should probably also put down this y-intercept over here. To understand what exactly this would be, just think about it like this. If it is at 0 degrees, remember that this graph was shifted 60 degrees to the right. So this solution, right, this y value, where was it initially before the shift? It would have appeared 60 degrees to the left. So for us to find out what exactly this y value is, find out what cos of negative 60 degrees is, since this value shifted to the right to end up at 0 degrees. That's why we have this over here, 0 degrees, and that answer. So what is cos negative 60 degrees? That's what we will need to find out. You could use a calculator or use reductions, but cos negative 60 degrees would simply be equal to a half. Okay, if you use the reductions, you'll see that it would be that. So we know what that is now. That is now 0 degrees and a half. 0 degrees and a half, but we don't have to say 0 because we can see it passes 0. It's the y-axis. So simply just say a half. And that may be helpful along the line with the questions. And that is our answer. That is what the graph of G would look like. Question 7.2 says, write down the period of f of 3x. So do you notice that this is normally supposed to say f of x, but they've replaced x with 3x. So it just means that in the equation of f, replace x with 3x. If we did that, then we have a 3 now in front of the x, which is going to affect the period. To find the new period, you can take the original period. Looking at the graph of f, it is a sine graph. So the original period of a sine graph is 360 degrees because it takes the sine graph 360 degrees to complete one cycle. And then this cycle, again, this pattern would repeat itself 360 degrees later and even before that. So we'll take the old period, 360 degrees, and we'll divide it by the coefficient of x. And so our period is equal to 120 degrees. This graph is going to complete one cycle in 120 degrees, which means it's going to be more narrow. Okay, moving on to the next question. Question 7.3 says, use the graphs to determine the value of x in the interval where x is an element of negative 180 degrees to 180 degrees, for which f of x minus g of x is equal to 1. Here, you really just need to think about combinations where you say a y value of f minus a y value of g, and then they give you 1. So these can be numbers like 2 minus 1 or 1 minus 0. These all give 1. So if we can find places where the graph of f and the graph of g are equal to numbers like this, this could work. Okay, so you could inspect the graphs and just see where this happens. Another way to think about this is we could rewrite this equation as f of x is equal to and transpose g of x. So it's now positive g of x plus 1, meaning look for places where f of x would be exactly equal to where they would intersect if you took g of x and you shifted it up by 1 unit. That's another way that we could think about. So, okay, if we took the graph of g, I'm just taking half of it, and we shifted up by 1 unit, see the important places, like over here it's at 0. If you shift it up by 1 unit, it's actually going to intersect perfectly with the graph of f. So at that point over there where x is equal to negative 30 degrees, that's where that solution would be. So if we put it back there, you see that here the graph of f has a y value of 1. And if you said f of x, right, that y value of 1 minus g of x, this over here has a y value of 0. You see that 1 minus 0 is 1. Okay, so there we go. It will happen here at negative 30 degrees. And if we wanted to see whether there were any more solutions, we could still think about it as shifting that up. If you shifted everything on g up by 1 unit, would you have any other place where they intersect? And yeah, it actually does intersect somewhere else. And I don't even think this was intended to happen. But what we can do is just go with the x equals negative 30 degrees because this question was specifically a 1-mark question. Okay, so we can just tell them this is where x is equal to negative 30 degrees. And that is our answer. Moving on to the next question. Question 7.4 says, write down the range of k if k of x is equal to a half g of x plus 1. Okay, so it's the graph of g of x. And with the graph of g of x, you see that there was no upwards or downwards shift. So it's just really this graph. We don't have to, over consider that x minus 60 degrees because that affects the x values, not the y values. At the end of the day, this graph is still a cos graph. So the highest that the normal cos graph, the natural cos graph, cos x, would reach would be 1. Now, since this one has a coefficient of a half, okay, it's just going to be a half cos x minus 60 degrees. It means that the highest it will reach would be a half when we just apply that a half. Okay, so it still looks like the image that we have, but we don't have to overthink the way that looks. So it just goes like that. We can just draw that there, of course, for reference sake. Okay, so something like that. And then I'm just replicating it over here. So now the highest that it's reaching is a half when we just apply that half. And then the lowest would be at negative a half. But then this graph is shifted up by 1 unit. So now what is the minimum going to be? Where will that y value of the minimum be? If it shifts up by a half, from negative a half, just add 1. That's going to be at positive a half. So it shifts up. We're just going to have to shift this graph a bit lower. It's going to just simply look like this. So from where it is, it's shifting up by 1. And now the minimum, the y value is at a half. And the maximum's y value would be at, this maximum was at a half. You're just going to add 1 to that. So plus 1 would be at 1.5, which is 3 over 2. So that's 3 over 2. So it means that it reaches a maximum of 3 over 2 and a minimum of a half. That's what it's going to look like. Okay, so the range would be all the possible y values of this graph. Since it has every single y value, but it does not go beyond or below a half and does not go above 3 over 2, then the y values would look like this. So the range should be y is greater than or equal to 1 over 2, but less than or equal to 3 over 2. And that will be our answer. So we can, of course, write this as a set. So in set builder notation, which would be y is an element of, and we're going from 1 over 2 as an included y value all the way to 3 over 2 as an included y value, and that's why we're using square brackets. So you can write it like this or like that, and that'll be perfectly fine. Okay, so that is the answer. That will be the range of k. And that is it for question 7. Question 8 says, in the diagram below, T is the hook on the ceiling of an art gallery. Points Q, S, and R are on the same horizontal plane from where 3 people are observing the hook at T. Okay, the angle of elevation from Q to T is X, that's over there, and we are given that angle QSR is 90 degrees plus X, angle QRS is equal to X, and QR is 5 units, and TS is equal to SQ. Okay, and the first question is to prove that QS is equal to 5 tan X. Okay, so notice that with QS, it has 5, which we could see 5 is the side QR, and it has tan X, so it's in reference to X, it's in relation to X. So they've clearly used this triangle down here. So this is a case where we don't really have any right angle triangles, so we're not using trig ratios. Okay, let's see how we can find QS. Using this triangle that we have below here, QS is this side here. To find this side, we can focus on using the sine rule just because of the angles that we have here as well. So the angle opposite QS is X. And then we also have another paired angle and side that is complete here. We have 5 units, and opposite 5 units, we have 90 degrees plus X. So let's go ahead and use the sine rule. So the sine rule, but we'll make QS the subject, the side the subject. So we're saying QS over sine of the angle opposite it, which is that angle X over there, is equal to, and you have to follow the same order. If we said side over sine angle, we also need to say side, which is this 5, over sine of the angle. So that is sine of 90 degrees plus X. And all we have to do here is make QS the subject of our equation. So QS would be equal to, you could multiply both hand sides by sine x to get that over there. So we're really just transposing it. And so that is going to be 5 sine x, because when it multiplies, it ends up in the numerator. Okay, so this is equal to 5 sine x all over sine 90 degrees plus x. That's a cofunction. So it simplifies to cos x. And there, that's where the tan comes from. So QS is simply equal to 5 tan x because of sine x over cos x. And that is our answer. Question 8.2 says, prove that the length of QT is 10 sine x. So let's see, QT. Now that we have this as 5 tan x, then how do we find QT? Well, there's also other things that we know here. Because QS and ST are equal, then this is also 5 tan x. So using the information we have, how do we find QT? Okay, we could also use the sine rule here just because of the relationship between the sides and the angles opposite it. So we've got two sides in this triangle, but we also have an angle. Okay, we have an angle, and this one pair is complete. You've got an angle and you have a side opposite the angle. So that pair is complete. Now to find QT, we simply need to find the angle opposite QT, which is this angle over here, QST. And we can find this since these two sides are equal. We have an isosceles triangle. So if this is equal to x, then this angle over here is also equal to x because of the isosceles triangle. So we can tell them that firstly, QTS is also equal to x. So angle QTS is equal to x because we have an isosceles triangle. And so because of that, we can find this center angle over here, QST. We'll find that by saying 180 degrees minus x, which is 180 degrees minus 2x. So that angle QST, is simply equal to 180 degrees minus 2x using the sum of angles in a triangle. So that's what this is, 180 degrees minus 2x. And now we can finally find QT because we have the angle opposite it. So we're using QT and the angle opposite it. So we'll say QT over sine of the angle opposite, which is 180 degrees minus 2x. That's QT over sine 180 degrees minus 2x. And this will be equal to, we'll take another pair that is complete. And the other pair that we have complete is these, well, both are complete really because they both have 5 tan x. So you can just pick one. We can just go ahead and take this. So we'll take in 5 tan x as the side opposite sine x as the angle. Okay, so that's 5 tan x over sine x. And now we can just go ahead and multiply both hand sides by that denominator so that we can leave QT there. So it's like transposing this from the denominator, it will move to the numerator. So QT is equal to, we have 5 tan x, and this is multiplied by sine 180 degrees minus 2x, and this goes all over sine x. Okay, so let's simplify. QT is simply equal to, we can use the identity of tan x, so that's going to be 5 multiplied by, that is sine x over cos x, and this is multiplied by, when we simplify that using the reduction, you see that it is in sine's quadrant, 180 degrees minus an angle. Okay, so this will reduce to sine of that angle, 2x, and this goes all over sine x. Okay, at this point, you can cancel out these two in the numerator, but here's another thing we could do just to make this look more simple. We're saying 5 multiplied by, and let's just say that was still left the same. It was still sine x over cos x. Then we could use the double angle identity for sine 2x, which is 2 sine x cos x, and this goes all over sine x. Okay. And now you see that sin x and sin x will cancel here. And now you're left with, in the numerator, you have sin x over cos x multiplied by cos x. This cos x, right, despite the fact that they're all in the numerator, this cos x is in the numerator as in it has a denominator of 1. So it will cancel with this cos x in the denominator. And all we have left is that qt is simply equal to, we have 5 multiplied by 2, which is 10. And then the only thing left in the numerator is the sin x. So 10 sin x, just like they said qt would be equal to. So qt is equal to 10 sin x. Moving on to the next question. Question 8.3 says, calculate the area of triangle TQR if TQR is equal to 70 degrees and x equals 25 degrees. So let's look at that triangle TQR. Okay, just remember that we just found QT. That is now 10 sine x. And they want us to find the area of triangle TQR. And they give us the angle TQR, this angle over here. That is 70 degrees. Okay, so you see that we can use the area rule here. We've got the middle angle. We have a side next to that middle angle and another side next to the middle. And what it's going to look like is that the area of triangle TQR is simply equal to a half multiplied by the side QT. We can't just write it down in full first. That's QT multiplied by the other side QR, which we know is 5 units, and then sine of that center angle, which they told us the size of, okay, which is that angle TQR again. So that's what our formula would look like. Okay, so this is equal to a half multiplied by QT, which is 10 sine x, and multiplied by QR, which is 5 units, and then sine of this angle, which we know is 70 degrees. Okay, so we're just going to substitute where necessary. So in place of x, we can substitute 25 degrees because they told us that already. Okay, so it looks like that. And then finally, let's just find that answer. And that area is equal to 9 point, and that's going to round up. So adding a 1 to the 2 there. So that is 0.93 units squared. And that is the area of triangle TQR. And that is it for question 8. Question 9 says, in the diagram, PQRS is a cyclic quadrilateral. PS is produced to W. TR and TS are tangents drawn to the circle at R and S respectively. And then they tell us that angle T is 78 degrees and angle Q is 93 degrees. And the first question, 9.1, is to give reasons why ST is equal to TR. Okay, so from the information, they already told us that ST and TR were tangents to the circle at R and S. Now, if these are tangents to the circle, as you can see, they're drawn from the same point T and they're drawn to the circle. So they are equal because tangents drawn from the same point to a circle are equal. Okay, so we just have to tell them that. And there we go. Tangents drawn from the same point to a circle are equal. Moving on to the next question. Question 9.2 says, calculate given reasons the size of, and the first one we need to find is the size of angle S2. So where's angle S2? Now remember, we already know that ST and TR are equal, so we can't just put that there so we don't forget that. They need us to find angle S2, which is this angle over here. Now we have an isosceles triangle since those two tangents are equal. Since we have an isosceles triangle, we can use the sum of angles in the triangle to find this. So we're adding angle S2, angle R2, and 78 degrees, and they give us 180 degrees. So angle S2 plus angle R2 plus 78 degrees is equal to 180 degrees, and this is because of the sum of angles in a triangle. Okay, but now we also know that because these two sides are equal, we have an isosceles triangle, and therefore angle S2 would be equal to angle R2. So we can also tell them that angle S2 is equal to angle R2 because of angles opposite equal sides are equal. And since we already now know this, we can update our equation. So our equation is actually angle S2. And then in place of angle R2, since angle S2 and R2 are equal, we can just replace it with angle S2. Plus 78 degrees is equal to 180 degrees. And so this is 2 angle S2 is equal to 180 degrees minus 78 degrees, which is 102 degrees. And so 2 angle S2 is equal to 102 degrees. And if we divide both hand sides by 2, then finally angle S2 is going to be equal to 51 degrees. So angle S2 is equal to 51 degrees. And there we go. We have solved for angle S2, given reasons. Moving on to the next question. The next question says we need to find the size of angle S3. Okay, let's just fill in what S2 was. If S2 is 51 degrees, and of course that's also 51 degrees, how do we find angle S3? Okay, so looking at the diagram and looking at where angle S3 is, do you remember that this shape is a cyclic quad? And in a cyclic quad, the exterior angle of the cyclic quad is always equal to the opposite interior angle. So this means that angle S3 plus angle S2, which is 51 degrees, they should give us 93 degrees. So we can tell them that angle S3 plus angle S2 is equal to 93 degrees. And that is because of the exterior angle of a cyclic quad. And so, therefore, angle S3 plus this is 51 degrees is equal to 93 degrees. So we'll find angle S3 simply by saying 93 minus 51 degrees, which is 42 degrees. And that is our answer. And that is it for question 9. Question 10 says, BE and CD are diameters of a circle having M as center. Chord AE is drawn to cut CD at F, and we are also told that AE is perpendicular to CD. And lastly, let angle C be equal to X. Okay, the first question is give a reason why AF is equal to FE. Okay, why are these two lengths equal? Well, they told us that CD is a diameter. And so we have a line coming from the center of the circle perpendicular to this chord AE. And so therefore, it would bisect the chord. So that is why they are equal, okay, because of that first theorem. So we can just put that down. Okay, line from the center of the circle perpendicular to the chord. And moving on to the next question. Question 10.2 says, determine given reasons the size of angle M1 in terms of X. So we can note down from the previous question that AF is now equal to FE, just in case it may help us in the next questions. And now to find the size of angle M1 in terms of X. We can focus on where this angle is in particular. Do you notice that it is at the center? Okay, it's at the center of the circle. So we can use theorems related to angles at the center. We know that the angle at the center of the circle is equal to the angle at the circumference as long as they are supported by the same chord or arc. So in this case, we have an arc CE. Is there any other angle supported by CE? Yes, if we extend this, you see that we have another angle, angle A1, which is supported by CE, and angle A1 is at the circumference. So the angle at the center is double the size of the angle at the circumference as long as they are supported by the same chord or arc. So clearly, in order to find angle M1, we need to find angle A1. Okay, so let's focus on finding angle A1. How can we find angle A1 in terms of X? Well, angle A1 is part of a triangle that includes X. So to find angle A1, remember that the sum of angles in a triangle add up to 180 degrees. So we can say 180 degrees minus 90 degrees, because that's the other angle here, and then minus x, and that would give us angle A1 because of the sum of angles in a triangle. And therefore angle A1 is equal to 90 degrees minus x, and this is because of the sum of angles in a triangle. Okay, and then to find the main goal, so this is 90 degrees minus x, and now to find angle M1 is at the center, so it's going to be double the size of this angle. So we can go ahead and tell them that angle M1 is equal to twice the size of angle A1 and put our reason down, okay? And therefore, angle M1 is simply equal to twice the size of angle A1, which is 90 degrees minus x, and therefore angle M1 is equal to 180 degrees minus 2x once we distribute. And that is our answer. Okay, and then once we put that down, it is also advisable to make sure you note that down here. Okay, moving on to the next question. Question 10.3 says, prove given reasons that AD is a tangent to the circle passing through A, C, and F. So let's go ahead and look for that. We are trying to prove that AD, this line, is a tangent to the circle passing through the points A, C, and F. So let's go ahead and draw a circle here first and then see how that is possible. Okay, so here is our circle, and we just need to prove that this is a tangent to the circle passing through these points. In order to prove in this situation, because they never told us anything about this being a diameter, but in order to prove that a line is a tangent to a circle, you have to use theorems related to tangents. So there are some theorems that we can use or we can consider. They are tangents from the same point, but we cannot use that clearly because we only have one tangent or one line that we're supposed to prove is a tangent. We could also use, there's also the tan perpendicular to radius. The tangent is perpendicular to the radius at the points of contact, but we don't have any radius in this diagram. So we can stick to the tan chord theorem, and that's what we're going to go with here. Okay, so showing them that the tan chord theorem is true in this diagram, the way we can do that is if this is supposed to be a tangent, then this is the chord we will look at. And so the angle between the tangent and the chord is equal to the angle supported by the chord at the circumference. So in other words, we need to prove to them that angle A2 is equal to x. That's what we are required to prove. So we are required to prove that angle A2 is equal to x, or is equal to angle C, which is therefore equal to x. So how can this be equal to x? Well, looking at the bigger diagram, they told us something about this, because since this is at the circumference, we have to look at the other lines or angles that it's related to. Sure, it's related to this triangle over here, but we don't really have any other information there. But we do know that CD is a diameter. So if CD is a diameter, then it means that the angles A1 and A2 are supported by this diameter CD, and therefore they form a 90-degree angle. So angle A1 plus angle A2 is equal to 90 degrees, and that's because of angle in a semicircle. Okay, and we already know the size of angle A1. It's 90 degrees minus x. So in order to find angle A2, we'll just say angle A2 is equal to, we have 90 degrees. And if this was 90 degrees minus x, when you transpose it, the 90 degrees becomes negative and the x will become positive. And so therefore, angle A2 is actually just equal to positive x. And there we go. If angle A2 is equal to positive x, then you see that we have proven that the angle between this supposed tangent and this chord is equal to the angle supported by that same chord. And so since the tan chord theorem is true for this circle and this line that we're trying to prove is a tangent, it therefore means that this is a tangent. Okay, so we can just conclude and tell them since angle A2 is equal to angle C, which is of course equal to X, this concludes that, and then we'll just take the conclusion from here, that AD is a tangent to the circle passing through A, C, and F. And the reason for this is not the tan chord theorem. We proved that the tan chord theorem was true, okay? So the reason for this would be the converse of the tan chord theorem, okay? Because really what we did was we didn't call this a tangent and say that this is therefore equal to x because the angle between the tangent and the chord is equal to the angle supported by the chord. No, we showed them that they were equal, and so therefore the angle between the tangent and the chord is equal to the angle supported by that same chord. Okay, so it is the tan chord theorem's converse that we use there. And so we can just say converse of tan chord theorem for our reason. Okay, and that is our answer. Moving on to the next question. Question 10.4 says, given CF is equal to 6 units and AB is equal to 24 units, calculate given reasons the length of AE. Okay, so let's look at our diagram. If we are told that CF is 6 units and AB is 24 units, we need to find the length of AE. Okay, so they're giving us lengths in this triangle over here and this triangle over here. Now, in order to actually find it, you need to have some sort of strategy. There are different ways to find it, but focus on one way instead of finding random things. So here is something that we could focus on. We could focus on the fact that we have a triangle over here. And this triangle is definitely a right angle triangle because we can see that this angle at the circumference, A2 plus A3, right? They're supported by a diameter. So that's something we can't state just so that we can focus on that right angle triangle. And in this right angle triangle, we have been given the length of AB. So if we have to find AE, the only thing we need to know is the length of BE. If you know BE, and since we have AB, we can use Pythagoras to solve for AE. Okay, so let's go ahead and just state some important things. To be able to consider this as a right angle triangle, we need to also acknowledge that that is indeed 90 degrees. So let's go ahead and tell them that angle A3 plus angle A2 is equal to 90 degrees because it's supported by this diameter BE. Okay, angle in a semicircle. Okay, so that is out of the way now, and we have that down. Now we can focus on finding BE. Now BE is twice the radius, okay, because it is a diameter. If we can find out what the radius is at any point really, then we'd be able to find the full length of BE. So let's look at how the radius has been drawn throughout this diagram. We have a radius over here, M to D, okay, center to circumference, but that's not very helpful because of where it is. We have M to B, but that is also part of what we're looking for. And then we have from M to C, and they gave us CF for a reason. So it means that if we knew what this was, we would be able to find this radius. So we need to focus on FM. How can we find FM? Now, if you focused on FM, you would notice that it is part of this triangle. And this triangle, there's something interesting going on here. You see that in this triangle, EF and FA are equal, okay? But we also have two equal sides as well next to it. So ME is equal to BM since they are radii. So we have the case of the midpoint theorem going on here. And that's what we can use to find FM. Because once we are able to prove the midpoint theorem, it means that these two lines would be parallel first, but it will also mean that FM is half the size of AB. Or you can say that AB is twice the size of FM. And that would help us to find FM. Okay, so the goal is to use the midpoint theorem here. To use the midpoint theorem, we just need to show them, because we already know those two are equal. We just need to conclude that ME is actually equal to MB. And let's go ahead and do that. So these two are equal because they are equal radii. Okay, ME equals MB because they are equal radii. Okay, and now that we have that, we have the midpoint theorem over here. And since we have this, we can conclude. Let's just go ahead and just state as well that FE was already equal to FA because we had that already. So FE is equal to FA, and that was already given. Technically, it's, I want to say proven, but it's fine to say given because they did tell us to give them a reason why those two lengths were equal initially. Okay, so this was already given. And now that we have all of this, we can finally use the midpoint theorem to prove what we are focused on proving. Our focus is mainly that FM is half the size of AB. Okay, or we can also just say AB is twice the size of FM because of that midpoint theorem. So AB is equal to twice the size of FM because of the midpoint theorem. Okay, because of the midpoint theorem. And we already know what AB is. It's 24 units. So 24 is equal to 2 FM. And if you divide both hand sides by 2, this means that FM is therefore equal to 12 units. And there we go. If we have FM now, we can actually find this. So if this is 12 units, as you can see, the diagrams are not drawn to scale. If that is 12 units, then it means that the radius from M to C, that radius now is 18 units, and then all the other radii will also be 18 units. So we can conclude that CM is equal to 18 units. So therefore, CM equals 18 units. And of course, CM is equal to the other radii as well. That's going to be important because we need to add those up together. So CM is equal to MB and ME. Okay, and now that we have that, we're trying to use Pythagoras here. So since this is 18 units and that's 18 units, then the full length of BE is 36 units. So we can conclude that therefore BE is equal to 36 units. Okay, and now that we have that, we can finally find the length of AE. Okay, so here's the whole thing. This is a right angle triangle and we have shown it is right angled. Okay. And now we have AB and we have BE. Since we have those two lengths, we can find AE using Pythagoras. So AE squared is equal to, that is equal to, the longest side was the hypotenuse BE, so BE squared minus the other shorter side, which was AB, so AB squared. And we can just tell them theorem of Pythagoras, or just say Pythagoras. Also, I forgot to tell them why those were equal. It's because they're equal radii that we have. All those are equal radii. Okay, so because of Pythagoras that we have there. And now we're just going to substitute our values. So AE squared is therefore equal to BE, which is 36 squared, minus AB, which was 24, so 24 squared. And let's go ahead and find out what exactly that is quickly on the calculator. And that is 720. And then we can find the square root of both hand sides. We don't have to consider any negative solutions since we are working with lengths, and lengths are always positive. So the square root of 720 is finally equal to 12 root 5. Okay, so you can leave it as 12 root 5 or round off to two decimal places, which would be 26.83 units, since it's not in centimeters or meters or any other unit of measurement. And that is the final answer. And that is it for question 10. Question 11.1 says, in the diagram, chords DE, EF, and DF are drawn in the circle with the center O. KFC is a tangent to the circle at F. And the question is to prove the theorem which states that angle DFK is equal to angle E at the circumference. Okay, so just based on what they are asking for, notice that this is on the left-hand side, okay? Since they want us to prove that DFK, this angle over here, is equal to this angle, here's how we're going to draw this diagram. You see, the angles that we're going to create are going to have to be focused at this point over here. So we're going to first of all draw a diameter. And the diameter is going to be connecting this radius OF, and it's going to just extend all the way to this point, which we can call anything really. So I'll call that P, a point P. Okay, now remember the angle needs to be focused on this side, since the angle we're trying to prove it's equal to is this angle over here. It's on the left, so you need to focus on the angle on the left as well. So what we're going to do is draw a line joining P and E together so we can create another angle at the circumference there, and that's going to help us to prove this. Okay, and then it's important to just make sure that you write down any constructions that you have made. So let's go ahead and write that down. Okay, so draw diameter PF and line PE. Okay, so we are required to prove that the angle between the tangent and the chord is equal to the angle supported by that same chord. Of course, you have to do this without actually using that theorem. So let's go ahead and name these angles. So we can call this angle F1, and that's angle F2, and this is angle E1 and angle E2. So looking at angle F1 and angle F2, if we add them up, they will give us 90 degrees because the line from the center of the circle to a tangent is perpendicular to that tangent at the point of contact. So we can tell them that angle F1 plus angle F2, that they add up to 90 degrees. And that is because we have a radius being perpendicular to the tangent at the point of contact. Okay, so that is down first. And we also have another case going on here. It's not the same case, of course, but they also add up to 90 degrees. Angle E1 plus angle E2 will give us 90 degrees for a different reason. And the reason for that is because PF is a diameter. And so angle E1 and E2 are jointly the angles supported by a diameter. So it's the angle in a semicircle. So we can also see that angle E1 plus angle E2, that they also add up to 90 degrees because of angle in a semicircle. Okay, now that we have shown them that they both add up to 90 degrees, this does not prove that they're equal yet. However, if we can prove that one of them, one set is equal, like F1 is equal to E1, or that F2 is equal to E2, it would mean the other pair would be equal as well. So that's what we're going to focus on. Let's look at those angles and see how are they actually equal to each other. Okay, so looking at it like that, you see that angle E2 is supported by this arc DP. But we also have another angle at the circumference supported by DP, and that is angle F2. So that will mean that they are equal because of angles in the same segment. So angle F2 is equal to angle E2 because of angles in the same segment. Okay, angles in the same segment are equal. And now since we've got one pair being equal to each other, that automatically proves that F1 is equal to E1 since they have to both add up to 90 degrees. So it's kind of like this, let's say it was 60 degrees. And then we also found that, okay, since they're equal, E2 is also 60 degrees. So that would mean that F1 and E1 both have to be 30 degrees for them to add up to 90 degrees. Okay, and that's how we prove that. So therefore, angle F1 is indeed equal to angle E1. So that means we can finally conclude angle F1 was the angle DFK and angle E1 was the angle E. So we can finally just tell them that this means that angle DFK is indeed equal to angle E. And that is how we prove this theorem. Question 11.2 says, in the diagram, PK is a tangent to the circle at K. Chord LS is produced to P. N and M are points on KP and SP respectively. such that MN is parallel to SK. Chord KS and LN intersect at T. And the first question is to prove, given reasons, that angle K4 is equal to angle NML. Okay, so let's look at the diagram. Okay, so angle K4 is here. So it's the angle between the tangent and this chord KL. So it's going to be equal to the angle at the circumference in the circle supported by this same chord KL, which we can see is this angle S1. Okay. From angle S1, where is S1? It's at the circumference, yes, but you see that it's also next to this parallel line. So we can go ahead and use fun angles here. So angle S1 is this angle over here. So it's going to be equal to this entire angle because of corresponding angles. It creates an F. So that is angle NML. Okay, and that is why they are equal. So we can go ahead and tell them that angle K4 is equal to angle S1 because of the tan chord theorem. So angle K4 equals angle S1 because of the tan chord theorem. And then we also know now that angle S1 is equal to this angle over here, which is angle NML because of corresponding angles on parallel lines. So we can tell them that angle S1 is equal to that angle NML, and that is corresponding angles. So corresponding angles, and make sure to state the lines that are parallel. Okay, because MN is parallel to SK. And now, because these angles, angle K4 is equal to angle S1 and angle NML is also equal to angle S1, it would mean that they are both equal to each other. So we can finally conclude that this means that angle K4 is indeed equal to angle NML. And that is our answer. Just ensure that you also leave these because it's probably going to help you with the next question. Okay, moving on to the next question. And then B says we need to prove that KLMN is a cyclic quadrilateral. Okay, so that is this quad over here. Okay, so since we are looking at that, and I guess here it's already very clear, but just remember the three theorems that you have to prove that a shape is a cyclic quad. And here they are. If we can prove that the exterior angle of this quad is equal to the opposite interior angle, then it is a cyclic quad. If we can also prove that the opposite interior angles add up to 180 degrees, then it is also a cyclic quad. And lastly, if we can prove that the angles in the same segment, meaning those angles at the circumference supported by that same chord or arc, that they are equal, then it's also a cyclic quad. But in this case, it is quite clear because we can see that the exterior angle of this quad is actually equal to the opposite interior angle. This is something we've already proven. We show them that angle K4 eventually is equal to angle NML. So in this case, we can just go with this theorem. So we're concluding that we're telling them that angle K4 is equal to angle NML, which is the exterior angle. And that has been proven already in the previous question. So we can tell them this has been proven. And because of that, that would conclude that KLMN is indeed a cyclic quad. And the reason is because we had the exterior angle being equal to the opposite interior angle. So therefore, it is a cyclic quad. And there we go. We have proven that the shape is a cyclic quad. Moving on to the next question. Question 11.2.2 asks us to prove, given reasons, that triangle LKN is similar to triangle KSM. So let's go ahead and highlight those triangles in our diagram. Okay, so in this diagram, remember that, and this is probably why I shouldn't have erased those lines, but remember that we have already proven that the shape KLMN is a cyclic quad. So we're going to focus on that as a cyclic quad because it's just going to give us more information and more room to make angles equal to each other. So if that shape is a cyclic quad, let me highlight it. Now in the cyclic quad, focusing on, because we need to focus on the angles. And one way to focus on the angles is to just look at how they were named. These angles were named as triangle, LKN, and KSM, meaning they are similar in that order. Okay, so I've pinned it to the screen and we can just look at it like that. So here are our triangles. If we're looking at it like that, then it means that the L in this one triangle will go with a K in the other triangle. So L will be this angle over here, and the K in this triangle, the blue triangle, would be K2. So let's look at those and see how are they equal. Well, first of all, we know that this shape is a cyclic chord. So do you see that from one end of the chord, if we connect it, we have one diagonal here, and then we have another one. And now with these, we can see that this forms angles in the same segment. Okay, so this would be KN, that's the chord supporting the angle, angle M2, and this angle, angle L1, okay, in that cyclic chord, the green cyclic chord. So those would be equal. So now we have moved from angle L1 to angle M2. Now notice that angle M2 is next to a parallel line. So we can form alternate angles over here. And there we go. So angle M2 is equal to angle K2. So let's go ahead and start off with that. We'll introduce our triangles and then show them that those two angles are equal. Okay, so in this, we're first saying that we have angle L1 being equal to angle M2 because of angles in the same segment in that cyclic chord that we have. So angle L1 is equal to angle M2, and this is because of angles in the same segment. And then we have angle M2, so we've already shown that these two are equal. Then angle M2 is equal to angle K2, and that is of course because of alternate angles. And we'll just tell them the lines that are parallel as well. Okay, so just tell them that angle M2 is equal to angle K2 because MN is parallel to SK, okay? And so because these two angles are both equal to angle M2, that concludes that angle L1 is equal to angle K2. And those are two angles in those triangles. So we found these two. And then we need to find another pair that are equal. Now, this is actually still using this same theorem. Okay, you see in this cyclic chord over here, because of the lines going across, then we also have this situation where the angles in the same segment are equal. So angle M3 is equal to angle N3. Okay, so we can go ahead and tell them that. Okay, and that is in each triangle. So angle M3, this angle over here, is equal to angle N3. And that is also because of angles in the same segment. And because we have two angles in each triangle being equal, that and that those two are equal, then by default, the other two angles will be equal in each triangle. So we can finally just tell them that this last angle would be equal. It was LKN and KSM. So the other angles that we didn't really speak about yet was this angle here. Okay, all of that is actually equal to this angle, angle S2. Okay, so we can just tell them that. Let's just go ahead and call this angle LKN. So angle LKN is equal to angle S2 because we have two other angles equal. And your reason here can either be third angle in a triangle, or it can be the sum of angles in a triangle because they should add up to 180 degrees. So by default, they are equal. Okay, so with these three angles being equal in each triangle, then this finally concludes that triangle LKN is indeed similar to triangle KSM. Okay, and that is because of we have three sets of equal angles. So angle, angle, angle. And that is our answer. Moving on to the next question. Question 11.2.3 says, if LK is equal to 12 units and 3KN equals 4SM, determine the length of LK. Okay, so we can just put down the diagram, but first, let's just unpack what this means. If they say 3kn equals 4sm, then this is a ratio they're giving you. So you're supposed to have a length over a length, okay, that ratio is equal to a specific value. So we're going to divide both hand sides by, we're trying to keep letters on this side. So this is the letter on this side. We can just divide both hand sides by sm. And now that we'll have kn over sm and these would cancel, we want the numbers to stay on this side. So we have 4 here. The 3 needs to also come this side. So we can divide both hand sides by 3 as well. So this concludes that the ratio they're giving us is kn over sm is equal to 4 over 3. Okay, let's just get our diagram so we can better understand the information they are giving us. Okay, and the lengths they have given us, they gave us LK. So LK has been given, it is 12 units. And we have this ratio now. So this will just represent it as a ratio in the diagram. So instead of calling it 4, so there's no confusion with this. This is 12 units. That is just 4 as a ratio. So by Kn, we can just call this 4A. And then Sm, that's 3A. Okay, so looking at the proportions that they've given, you can see that they are using the two triangles which we proved was similar in the previous question. So we're going to go ahead and use that, okay, the proportions there, and we will find the lengths that they're referring to. Okay, so since this is what we already showed them, we can pick LK since they gave us that length. Now, if you take LK, you have to take this over KS. So they are really in proportion. So we're saying over KS that this is equal to, and then what else did they give us? They gave us the ratio of KN and SM. So we're going to have to take KN. And as you can see, when you take K and N, then the corresponding side is SM indeed. Okay, so that's SM. And that's what we have here. We have KN and SM. So because we have this, we can finally just conclude. And when we say this, we're going to, of course, have to tell them that this is because of similar triangles. So we can tell them it's because we had similar triangles. That's why we are able to use these proportions. Okay, specifically, these triangles were similar. So with this, we can go ahead and substitute. So LK is 12 units, as we have it there, 12 over KS, and KS is what we are looking for. That's the length. So we'll leave that as KS is equal to, and we know now that KN over SM is 4 over 3. So that is 4 over 3. And then you see that in order to solve for KS, we can start by cross multiplying. So that's going to be 4 KS is equal to 12 times 3 is 36. And then divide both hand sides by 4. Therefore, KS is equal to 36 divided by 4 is 9. So that's 9 units. And that is the length of KS. Question 11.2.4 says, if it is further given that NL equals 16 units, LS equals 13 units, KN equals 8 units, determine with reasons the length of LT. So let's just go ahead and get this diagram, and we'll also just remember that KS is actually equal to 9 units. Okay, so KS is already equal to 9 units, so just keep that in mind. But they're telling us that LN or NL is equal to 16 units. So that is this length over here. That is 16. So this is 9, this one. This is 16 units, so keep that in mind. And then they also tell us that LS is 13 units. So LS, this part is 13 units. And then we are also told that KN is 8 units. So KN is 8 units. Okay, that actually helps a lot. So them telling us this can actually help us to find out what exactly A is. And then anything in terms of A would also be able to be found. For example, like MS. Okay, so let's see how we can use all of this to determine the length of LT. Okay, so if we're just trying to find the length of LT, so we just want LT, this part over here, then it means that, you see the triangle we can actually use to find this. we can use this triangle LNM, because this triangle has a line drawn parallel to one side of it. So we can use the proportionality theorem over here. Now, in order to use that, when we're trying to find LT, so since this is missing, that's fine. We would need one of the lengths on this line. Now, they gave us the length of LN. So that's great. We can use LT over LN. Then on the other side of this triangle, this side, we would also have to have LS, which we do have. It's 13 units. And then this needs to go over LM. Okay, and then that's where the struggle seems to be. So we just need to find the full length of LM. If we can find that, then this is sorted. Okay, so to find LM, we need MS. But here's the thing. We were told the length of KN. So remember how in the previous question, we were able to use this, right? Because we knew that Kn over Sm is equal to 4 over 3. Okay, this was proven in the previous question. We can use this now to finally find the length of Sm, since we know what Kn is. Okay, so let's go ahead and use this ratio as it is. Okay, so I'll just go ahead and say since, and I'll go ahead and rewrite that. So since Kn over Sm is equal to 4 over 3, then we're just looking for Sm, knowing Kn. So Kn is 8 units over Sm. What we're looking for is 4 over 3. And now we can cross multiply. So that is 4 Sm is equal to 24. And then if you divide both hand sides by 4, then Sm is equal to 6 units. Okay, great. Now that we know what Sm is, we know the entire length of Lm, which is what we needed. So we can therefore say that Lm is therefore equal to 13 plus 6, which is 19 units. So Lm is 19 units, and that's going to help us. Okay, so with this, the only reason we would have here is that this was something that was proven in the previous question. So we'll just keep that there. Okay, and now let's go ahead and use the proportionality theorem on this. So looking at this again, you're using this triangle, and we're just going to go ahead and say we're taking LT over Ln, and this is equal to Ls over Lm. And the reason for this is the proportionality theorem. So we can just say this is because of the prop theorem. Okay, and let's go ahead and substitute. So LT is what we are looking for. We'll leave that empty. So LT over Ln, that is this entire length, which they told us was 16 units. Okay, so we'll say over 16 is equal to Ls, and Ls is 13. So that's 13 over Lm, which we found to be 19. And now we can finally find the length of LT. So you can just multiply both hand sides by 16 to get rid of that, since it's in the denominator. So LT is finally equal to, and if we multiply them, we get 208 over 19, but as decimals, we'll just round off to 2 decimal places. We can, of course, state that first, that this was 208 over 19, but for a better understanding of this length, we can put it in decimal form. So this is 10 point, and that's going to round that 4 up to a 5. Okay, that 7 rounds it up. So we have 10.95. And these, what unit of measurement were they in? They were just in units. So it is 10.95 units. And that is our answer. And that is it for question 11. Okay, so that is it for this paper. I hope you guys enjoyed it. And I will see you guys in the future videos.